Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter 5, exponents, polynomials, and polynomial functions. But most of all, we would focus on the third section, polynomials and polynomial functions. The objectives is to identify term, constant, polynomial, monomial, binomial, trinomial, and the degree of a term or and of a polynomials. We will define polynomial functions. We would review combining like terms, add polynomials, subtract polynomials, recognize the graph of a polynomial functions from the degree of the polynomial. So without further ado, let's say, when we want to identify polynomial terms and degrees of a term in polynomials, first of all, we need to understand what's a term. A term is a number or the product of a number and one or more variable raised to powers. So the numerical coefficient, or simply the coefficient, is the number factor of a term. So, if we have, you know, 2x y power 3, for example, the 3 in the front is the coefficient, but the whole thing right there is the term. Okay, so that's what we said. But constant, if a term constant or only a number contains only a number, it's called a constant terms, right? So if you have something, let's say if you have 2x squared plus 5, the 5 is a constant term. Or a polynomial in itself is a finite sum of terms in which all variables are raised to non-negative integer power and no variables appear in any denominator. So we call that a polynomial. It's a long expressions like 4x power 4y plus 6 x z, for example. This is really a polynomials, but if the exponent in the variable is not positive, then it's not a polynomial. So now let's see some vocabulary because it's important. In the polynomial, 7x power 5 plus x square y square minus 4xy plus 7, there are how many terms? We see we have 1, 2, 3, and 4. There are 4 terms. 1, 2, 3, and 4. The coefficient of the term 7x power 5 is 7. The coefficient of the term x squared plus y squared is only 1 because there is only one formula. The coefficient of the term negative 4xy is negative 4, and the coefficient of the term 7 is 7 because remember we said if you have no variable with a term, we call it a constant term. Now, for monomials, we have a different one. So monomial is an expression with only one term. So if it has only one term, we call it a monomial. So a monomial is a term with only, as we said, it has only one term. For example, a monomials we can do for 2xy squared. That's a monomials. A binomials has two terms. For example, 2xy squared minus 6x z. You see, you have two terms here. A trinomial have three terms. So, for example, if I have 6x cubed minus 3x squared plus 1. So there are three terms in the trinomial, exactly three terms. Well, we said after 3 we stop counting, so we call them polynomials. So what's happened when we have polynomials, monomials, as I said, those are a few examples. We may have ax squared, that's a monomials, or 3x, or 4, a B, and C. But we can do the same here. A binomials can be just 2x plus y. Uh, we call it A, B. We can have 6y squared minus 2.9. C for binomials. Let's say even it can be even fraction. 2/3 of x cubed minus 2x, two terms only, exactly two terms. For trinomials, is three terms, x squared minus 3x plus 2. Or we can have x squared plus 4xy plus y squared. We can have maybe 8y squared minus 2y minus 10 over 17. Those are just a few examples. We talked about a few examples. Now that you understand term, you understand constant, coefficients, and polynomials. I mean, monomials, binomials, trinomials, and polynomials. Polynomials is after three terms. We call all of them polynomials, but with no denominator. Now, we need to decide about the degree of the polynomials. The degree of the polynomials is very extremely important. The degree of a term to find the degree of the term is the sum, right? The degree of a term is the sum of the exponent on the variables containing in the term. Degree of a constant is always 0 because why? Because if I have 7, it's the same thing saying 7x power 0. Because remember, any number power 0 is equal to 1. So that's why we said, so because 7 times 1 is 7. So that's why we said 7. Degree of the term 4x power 4, A power 4, B power 3, C power 1 is 8 because remember we're going to do 4 plus 3 plus 1 give us 8. So C is power 1. We never write it down. Now, if we go with a few examples, what they ask you to do here is to find the degree of each term. First of all, focus on the variable, not the constant term, the coefficient, not the coefficient. So the degree here is only 2. The exponent on y is 3, so the degree is 3. Now, how about here? Don't count the 10 because you cannot count the 10. The 10 is a coefficient. You need to take x power 1, y power 1, that make it 2. So the degree, the sum of the exponent is 2. So the degree is 2. Degree is 2 because we add the sum of the exponent. What is the degree of that term? Because it's a constant term. It's simply a constant term. So degree is what? 0. Okay. So degree is 0. Well, if we talk about degree of a polynomials, to find the degree of a polynomials, you take the largest degree of any terms of the polynomials. For example, if you look at that examples where we have, 9x cube degree 3 minus 4x squared degree 2 plus 7 degree 0. You see the largest one is 3, so degree is 3. With this example where they ask you to determine the degree of each polynomial and indicate whether the polynomial is a monomial, binomial, or trinomial. So look at the first example. What is the degree? Yes, degree is 5 because that's the largest exponent is 5. What is that? Is that a monomial, binomial, or a trinomial? It has three terms, 1, 2, and 3. That's a trinomial. Okay? Because it has three terms, it's a trinomial. What is this degree then? The degree for B. Remember, the idea is to add all the exponents. You have power, x power 1, z power 1. When you add 1 plus 2 plus 1, degree is 4. Is it a monomial, binomial, or a trinomial? It's a monomial because it's only have one term. Even though you have negative 2 times x times y power 2 times z, it's only one term. There is no addition between the variables in the constant or the constant. Now, what is the degree? Please do not add this one because it's not a product. We add the exponent only on a product term, not when it's additions. Here, the highest degree is really 3. And is it monomial, binomial, or trinomial? Yes, it's a binomial because we only have two terms, not three and not one. Yes, that's a good way to start. Another example, they ask us to find the degree of that polynomial. First of all, we know this is degree is 3 here. Uh, what is that one? Yep, this one is 4. This one is 0 and this one is 3. Now, determine the degree. First of all, I identify which one has the highest exponent. When we see the term in the middle right here, when I add all the exponents, it gives me 4. Because of that, I will say the greatest degree of any term is 4. So the degree of that polynomial, degree of that polynomial is 4. Okay. Degree of that polynomial is 4. So if p of x equals 3x squared minus 2x minus 5, find, oh no, no. Right here, what we're doing is really defining polynomial functions. But in order to do that, the first thing to verify is to know how to evaluate functions. That means if the function is given, and if x is equal to certain things, how would you evaluate p of 2? That means everywhere you see x, you replace it by 1. So we're going to have 3 times 1 power 2 minus 2 times 1 minus 5. You see, we define there is no times because we don't have any x's. So 1 power 3 is 1 power 2 is 1 minus 2 times 1 is 2 minus 5. We have 3 minus 2 minus 5 equal to what again? Yes, -4. I'm hoping you good with those type of operations, with where the largest number has a negative sign. So if we do p of negative, that means we still go on the same functions. We substitute for -2 power 2 minus 2 times 2 minus 5. Again, we're going to be -2 times -2. 2 negative give you positive 4 minus, okay, 2 negative here would give us positive 4. So -2 times -2 give you positive 4 minus 5. Now, what we see, 3 times 4 is 12 plus 4 minus 5. I think you're really good enough for now, not for me to do every little tiny thing, just to know it is 11, right? Now, most of all, and the goal of doing algebra is to know how to combine like this, because not all the time we're going to deal only with x power 1, only with x power 2, only. Sometimes we might have a combinations of all of them. So we're going to do some combinations, combining of like terms review. So combining like terms are terms that contain exactly the same variables raised to exactly the same power. So that means if I have 2x squared plus 3x plus 1 plus 6x squared minus x plus 7, we're going to combine all the terms that has the same exponent. 2x squared plus 6x squared would give us 8x squared. We're going to do 3x minus x would give us 2x, and 1 plus 7 would give us 8. You see, we call that combining like terms. Only like terms can be combined through addition and subtraction. Remember that. Very important to keep that in mind. Simplify each polynomial by combining any like terms. You see here, because it has y, we know -4 plus 2 give you negative 2y. But here you cannot combine them because you have z power 1 and z power 3. If it was in multiplication, if you have z times z power 3, yes, you could combine, but here you cannot, can't. You can't. But power 3, power 3, yes, that means 15 minus 1 is 14x cubed. That is great. Now, sometimes you might have more than one. For example, power 2. Power 2, we can combine these two. That means 7a squared minus 3. 7 minus 3 give you 4a squared. Now, if we combine the constant term, negative 5 minus 7, two negative, remember when we in addition, same sign, we add and keep the sign. 5 plus 7 is 12, and we said negative 12. Okay? Very important that we do that. Most of all of that we do is to get to that point. This is it. Add polynomials. Our goal is to get there. We need to be able to add polynomials. To add polynomials, we combine, all like terms. That's what we would usually do. Because there is a positive sign in the middle, all we need to do, get rid of the parentheses first. So remove the parentheses, nothing is affected because it was positive. Now let's simplify. We only have one term with power 2. It's 4x squared, so we're going to keep it as is. Two terms with power 1, 3x minus 3x. What is 3 minus 3? 0. So I don't even need to put 0. I could say 0x if you want. And now we have negative 8 plus 3 give you negative 5. So if we simplify, we have 4x squared minus 5 should be the final answer for this one. We do that. Now, in some other situation, they would ask you using the vertical format. What's the vertical format? That means 8y cubed minus 4y squared plus 5 plus, because they said add, plus, I'm going to do 5y squared plus 1. We add. That's vertical format. Yes, maybe you forgot this. Remember when you add, you go from right to left, right? So 5 plus 1 is 6. Negative 4 plus 5y squared, both y squared, so that will give you only y squared. There is a plus in the middle right there. And we have left only 8y cubed. So this is the final answer for this. We're gonna see another example very quick. But don't forget, you can pause the video if you're not so certain of what we're doing. The access to add. First of all, verify multiple times, double check, and make sure you take like terms. These two seems to be the same. X power to y, x power to y, so that make it 11x power to y. We're done with this term. It's always better you cross them out once you're done so you don't get confused. Okay? The second one we're gonna go is xy, xy. xy plus xy give us 2xy. Now we're done. We're gonna cross and cross. We have negative y, negative 2y. Negative 1y, negative 2y give us negative 3y. Very simple. We combine like terms and group them together. We can also subtract polynomials. To subtract polynomials, you add its opposite, okay? Look at this one. The first thing to do is to distribute that negative, because if you want, remember this is 7x minus 8 minus 1 times 3x minus 12. Let's distribute that negative 1. The first parenthesis, no negative in front of the parenthesis, so we can just remove it. But negative 1 times 3x, negative 3x, negative 1 times negative 12, positive 12. Let's combine like terms for now. How are we gonna do it? We take these two. 7 minus 3 give us 4x. Negative 8 plus 12 give us 4. Final answer, because that's the best we can do. We might do even one looking a little bit more complicated than the previous one. Again, I'm going to distribute that negative. If you have a negative in front of a parentheses, if you want to get rid of the parentheses, it would change all the sign for the term inside of the parentheses. Those that were negative become positive, those positive become negative. For the first one, no negative in front of the parentheses, so nothing change. For the second, we end up with 3x cubed, positive 2x squared, negative 3. 2x cubed plus 8x squared minus 7x minus 3x cubed plus 2x squared minus 3. Combine like terms, x cubed, x cubed, so that make it negative x cubed because 2 minus 3 is negative 1. Now you're done with this one. Let's go with another one. We're gonna have 8x squared, 2x squared give us 10x squared. We're done. Now we have negative 7x alone by itself and negative 3 all alone by itself. So this is the final answer. Remember, this is a 2. Okay? I'm hoping those examples help, but remember we said when you, sometimes they can ask you to add or subtract, they don't need to tell you exactly what to do. They said add or subtract. So first of all, this negative would change all this sign. We're gonna have 4, 2 negative give you positive, 2 negative give you positive. So you end up with 8 plus y. And here, get rid of all the parentheses. Negative a squared plus 1. That negative become negative a squared. That negative become positive 3. Done with that one. Positive here, so nothing change inside of this parentheses. 4a squared minus 6a plus 7. Let's simplify. Negative a squared. Negative a squared gives us negative 2a squared plus 5a squared gives us 3a squared. So meaning we get rid of this, this, and this. Feel free to pause the video and look at it on your own. Now we have only negative 6a. We combine like terms. Remember, we have 1 plus 3, 4 plus 7, 11. 7, 11, right? That's what we obtain. Of course, we can do as many examples, probably a little bit more complicated than what we did before. For examples here, when we look at this one, there is a positive, so that means only remove the parentheses. Okay. Now we see 3x squared minus 2x squared give us only x squared. 8y squared minus y squared give us 7y squared. Okay. 8y squared. And we have negative 7xy plus 9xy give you 2xy. But it's better you write it as x squared plus 2xy plus 7y squared. It doesn't change anything because addition is commutative, but I like it for aesthetic. We can do more examples like here, but this time there is a negative with the second parenthesis. Distribute that negative, change all the sign inside. The first one stay as is. But for the second one, we're gonna have a negative for almost everything. You see, with that negative, those that was negative become positive, positive become negative. Now let's come by. At this point, it would be very important to be careful when you do that. Look for terms that has a square, b square. We have only one of them. You know what? I'm gonna use a different color. I'm gonna do 9a square, b square. That means I'm done with that. I can go with a sum. I see 7ab. I'm looking for order 7a, order ab. ab. So that's means 7 minus 3 is 4ab. Allez, allez, right? I say allez, allez. Now, negative 4ab square. That's the only one I have. Negative 4ab square. Gone. B power 2. Negative 6b power 2. Oh. I think I missed something because this is 6ab square here. No, b square a. I think this one has an a in it, right? Now I see it. I have what did I change? Uh, b 6b square a. So if we have 4ab square, right? No, not this one. This one was correct, right? 7ab, 3ab give you 4ab. Now, this one right there, I believe that will give us negative, because you do negative 4a b square minus 4b b square a is the same thing, right? If you want, you can rewrite it. Negative 4a b square minus 6a b square. That gives us negative 10a b square plus 10b square plus 4, right? Plus 4. I think that's it. That's it. Okay. This is a beautiful examples. All we need to do now is to complete these sections with recognize this graph of polynomial functions from their degrees. For examples, here using the degree of a polynomials, we can determine what the general shape of the function will be before we ever graph the functions. A polynomial function of degree 1 is a linear function, so this is just a straight line if it's degree 1. We have examined the graphs of linear functions in great detail in the previous videos. Feel free to check our previous videos. So a polynomial functions of degree 2 is a quadratic function. So anytime you have power 2, it's a quadratic functions, and the shape for a quadratic functions is a U shape that we call a parabola. So for the quadratic functions in the form ax squared plus bx plus c, we know we either have a graph open up or a graph open down. It all depends of the coefficient of x1, which is a. If a is positive, it's open up. If a is negative, it's open down. Polynomial functions of degree 3 are cubic functions. Actually, it's power 3 means you turn two times, 1 and 2. Okay, because if it was power 2, you turn only one times, power 2, x power 2, you turn one times. power 3, you turns 2 times. Now, what you need to remember here, you rise from left to right if coefficient of, coefficient, x cube coefficient is positive, so you rise from left to right. But if x cube coefficient is negative, you fall from left to right. You see, you fall like this, fall, rise like this. You see, you rise, going up, going up from left to right. If one examples are actually, we have only one example on this case where we're going to ask you to determine which graph shown below resembles the graph of f of x equal negative x squared plus 3x plus 6. The first thing to remember, if it's power to the highest degree is power to, what shape should be that graph? Should be a parabola. It's a U shape. Now, if you cancel B and D, your answer can be either A or C because it's power 2, it's only a U, open up or open down. Now, it's open up if the coefficient of x squared is positive, open down if the coefficient of x squared is negative. Now, if you look at here, you see C is the correct answer because it's open down as x squared has a coefficient negative. I hope you enjoy and have fun with these beautiful sections. In the different sections, we're going to come back to multiply polynomials. Take care. I'll see you in a different video.